today I would actually love to talk to you about a topic which I'm very passionate about, which is how we could actually use artificial intelligence to understand ourselves better. If I'm successful today, hopefully at the end of the talk, you will agree that we could use AI to learn more about ourselves and incorporate it into either machines or to just understanding of our cooperation. But before I dive into details, I'd actually love to give you just a brief overview of what I would like to cover. And the first question we're trying to answer is, why are we even doing this? And the answer is that I believe that intelligence, and not only me, there's loads of people, very smart people who believe that intelligence is a deeply social phenomenon. And I think we could build and observe the interaction between the artificial agents to understand ourselves better, our cooperation especially. But now we know that in some way, intelligence encapsulates social aspects. But how do we actually even use it? Is there a way to incorporate it? And even if we do, how do we use it for the benefit of the society? And what I'm trying to do in my experiments is I'm trying to look at the emergence of collective behavior, of how the agents themselves learn to cooperate with each other. And what's really driving me is I would love to test whether observing this would be able to help us apply to social sciences and artificial intelligence itself. And to start off, I'd love to define the intelligence, just because it will be popping up in my talk, but also I believe in the other talks. Of course, it's an open question. It's not like we can define it as one specific thing, but what we can do is we can roughly define it as something which measures an agent's ability to achieve goals in a wide range of environments. And what I really mean is that we're looking for something, and what we're really looking to gain, to achieve, is something which is more general, not something which is optimized for one specific thing, meaning learning to play chess or Go is a very cool thing, and you can show it up to other people, but ideally, we'll be able to create something which can learn to play backgammon, but then go and make scrambled eggs, and actually then maybe deliver a really good talk on the Science Polish Perspective conference. And what is really cool is that multi-agent environments are, let's say, an example of problem which encapsulate, firstly, the fact that it has to be more general because it has to, in some way, adapt and learn to adapt to their agents. And secondly, just because it's very practical. But there are other reasons, and there are other reasons why people are working on multi-agent problems. And the first thing is that we live in a multi-agent world. If you look around yourself, government, market, traffic, literally anything, this is an example of multi-agent system. And if this is the case, if all of this encapsulates social aspects, then in order to succeed, we actually need to learn to reply, to respond to the actions of their agents. Secondly, just from a practical standpoint, multi-agent design provides robustness, scalability, and flexibility, which is a great thing. And finally, my favorite argument, I think, is that human intelligence did not evolve in isolation. We like to think of it as something which emerges from our head, as something which in some way is inborn. But the truth is that intelligence is more of a process. It was being shaped by thousands of years, and is still being shaped. Every interaction with the environment, with other persons, with animals, this is crucial for the intelligence. And if this is the case, why should it be even possible to create AI by just looking from a single agent environment, single agent framework? But now we know that in some way it's crucial to look at multi-agent problems for the progress of AI. And for the remainder of the time, I'd love to focus on one specific thing, which is getting AI agents to cooperate. And how we studied in artificial intelligence is we use the notion of social dilemmas. And it might sound complicated, but in short, it's just a situation which exposes tension between a collective and individual rationality. And to try to bring it closer to you, this is thing we encounter every day. Free riding, not paying for tickets on the tube. Water turnout, public goods. In all of these situations, you may be tempted to act selfishly. But if we all do that, if we not pay for public transport, we'll all be worse off. And the aspect which I would love to look at specifically is the tragedy of the commons. And this is a social dilemma which has to do with a common shared resource. This is a tough word, but in reality, this literally means a resource which is shared among many people. And I like to explain it with an example of global warming, meaning global warming is a problem which, of course, touches all of us, and the shared resource is like environment, climate change. And if we really want to fight it, then we cannot act selfishly. But you'll be probably better off in getting this getting a juicy piece of beef instead of broccoli, or taking a plane instead of a train. But if we all do it, we will be doomed. But getting back to the main question is, okay, despite all these obstacles, can cooperation actually emerge in social dilemmas? And can it be stable? And this in no way is like a new question. This has been explored in nature and over like 50, let's say more than 50 years. But what is new is that we use deep reinforcement learning, which Dr. Mirovsky talked about, to imitate human behavior. And we deploy these algorithms, these agents using these algorithms, in a novel environment, which actually imitates the tragedy of the commons problem. And now, a cool thing, an exciting thing, is that we try to use it as a model in the social sciences, and draw conclusions based on it. But let's dive into the experiment itself. What you can see here is actually these red squares, which is an agent, and these green squares are apples. And in general, what they want to do is they want to maximize the number of the apples they collect. Each apple is each square. But the problem is that the regrowth of the apples depends on how many uncollected apples are around it. Meaning, if a guy collects, for example, this apple and all of these apples, then there are no apples around it, and it will not regrow. So the point is to actually learn a way to collect it sustainably. And what you can see here is that this guy finds like a circular way of achieving it, which is perfect, which is nice. They've actually both managed to find a sustainable way. But this isn't an easy thing. It's a single agent, and I've just done it to test the algorithms. What is really nice is the multi-agent case, where the agents not only have to learn a sustainable way of cooperating with each other, of trying not to fight each other, but they also can actually attack each other, which I just mentioned. They can freeze with this like white laser beam, and they have to find a way of not doing it too often and doing it in like a smart way. And what are the results? Okay. Luckily, both single agent and multi-agent have managed to successfully find a sustainable way of managing the resources. That is great bliss for me. But the problem is that in the multi-agent case, you can see like a sharp drop here. And this actually means that the agent, during learning, have led to a tragedy, which is not so great. But they bounced back and were able to actually find a sustainable way. And this is really cool because it was emergent behavior, meaning that it was not a fixed to do it. They were able to learn it themselves, solely based on the experience. Lessons learned? Firstly, the agents with limited cognitive capabilities, meaning that you're actually quite dummy, are capable of sustainable resource management. This is interesting because we often like to think of as like a domain of humans, which is actually not the case. Quite limited dummy agents were able to do it. But what is even cooler is that it opens avenues for further research. Both in social sciences, it allows for monitoring how different aspects affect the game. If we, for example, increase the observability, or if we change the attacking options, we can maybe see how it influences the game and maybe incorporate it into, let's say, of course, big picture, a treaty, a protocol of climate change. Secondly, is from artificial intelligence standpoint, from my perspective, it was really interesting to see how it captures more information that we usually see, because we often like to look only at the reward. But we can look at sustainability, peacefulness, and draw on it. Now, just to finish off, as I would like to highlight that this is like a very novel approach. And of course, we're in the very early stages. There is a lot to do, there's a lot to apply. There are more algorithms to test. But And so the road ahead is very long and bumpy. But I think that we should be very, very excited about it. Thank you.